All right, welcome to Algebra Chapter 8, Section 5. Today we're talking about GCF, which is greatest common factor, um, and or the distributive property. So up until now, we've been multiplying polynomials to get an answer. Now we're going to be going backwards. We're taking the answer and we want to know what kinds of things get multiplied together for that. So make sure you have this in your table of contents. And we're going to be on page 86 and 87, but you have two little pieces of O paper to help you out. So we are talking about the distributive property today. Now, there we go. Factoring. A polynomial in particular involves finding the completely factored out form of the polynomial. So everything that would be multiplied together in order to get that as an answer. And what we're going to be doing is we're going to pull out a GCF. I know you did this like a long time ago, and you're like, oh, well, why are we having to do that again? It's one of those things that you absolutely need to know. So that's what we're doing, pulling out a GCF. So let's take a look at one of these. So if I have 27y squared and 18y, I'm going to do like the tic-tac-toe board. So I'm going to write 27y squared. I'm going to be making a little box kind of thing. If you were here, you might remember this. You don't need the plus sign, although you could put it. And what I'm going to look for is I want to look and say, okay, what do each of these have in common? What can I divide by? And I'm going to do the numbers and then the letters. It doesn't matter. You could do the letters and the numbers. But between 27 and 18, what is the GCF? And so you could do the smaller numbers. If you might go, oh, well, look, 3 goes into it. You could do that. But if you can see, the greatest one is actually 9. They can both be divided by 9. So if I divide 27 by 9, that gives me 3. And then, of course, the y squared just stays on. 18 divided by 9 is 2. And then, of course, the y just stays on. So this is what's left. So now between 3 and 2, there's nothing else I could factor out. If I had done the original 3, I'd do another line of numbers for a second 3. Now, between y squared and y, they both have 1y, so I'm pulling 1y from each of them. So that just leaves me with 3y here and 2 there. All right, so now that I have that, this here, I'm going to multiply all of those together to get my GCF. That's my GCF, the greatest common factor. And then these down here are the polynomial that's left inside the parentheses. So that's going to look like 9y parentheses 3y. If there's not a minus sign or a plus sign, you always put a plus sign, so plus 2. So that is now factored. And voila, I'm done. All right, now let's look at one that's a little more complicated. So I have this. Once again, I'm going to go ahead and make my tic-tac-toe thing. So I have negative 4a squared b negative 8ab squared, and then 2ab. All right, so here's my tic-tac-toe. Now, first thing I'm going to look at is all the numbers. Between negative 4, negative 8, and 2, what can they all be divided by? Well, they can all be divided by 2. So now that leaves negative 2a squared b minus 4ab squared. This is just a 1. I could put it, but I don't need to. Okay, so that's all the numbers because there's not anything else that I can divide out. Now I'm going to do each letter. So this has an a squared, this has an a, this has an a. So they all have at least one a. So that leaves me with negative 2 because this is an a squared and I only pulled one of them. The a is still there. And then the b. and then -4. Now this a, there was only one of them, so there's not an a left, so b squared, and then this is just a b. Sorry, that's a sad looking b. So between, now if I look, this is a b squared, and a b. They each have at least one b, so I'm going to pull that out. So I have -2a left, -4b, and then if it completely goes away, it's going to be a 1. So all of these things here on the side are the GCF. And this that's down here is going to be the polynomial that I write. So the answer to this, once it's factored, is going to be 2ab parentheses -2a minus 4b plus 1. And that's it. That's how I factor. Okay. So make sure you get this page glued in on page 86, I think it was. Now let's move on to this page. Now, the other time we use GCF and all of this, I'm going to turn just a little bit, is when I'm doing factoring by grouping. Now, factoring by grouping, I have, anytime you see 4 terms, I said or more, which it does work with the or more, but 4 terms, you should be looking for this. You're finding a GCF and you need to watch out for additive inverses. So we're going to do a couple of examples because I'm sure you're like, what are you talking about? So since I'm grouping, what I'm going to do when I see 4 terms, I'm going to go ahead and put parentheses to group the first 2 terms, and then parentheses to group the second 2 terms. Now, if you need to make a tic-tac-toe board for these, you can, but we're just going to talk through it. So between the 4 and the 8, the GCF is a 4. Q, and there's not a Q, so I can't pull a Q out for this one, but an R and an R, so I can, both of them have an R. So this is my GCF. So I can look at it and go the numbers, and then each letter, what do they have in common, and pull it out. Or you could have done the tic-tac-toe over here on the side. So now I'm going to go parentheses. What's 4QR divided by 4R is just Q. 8R divided by 4R is going to be 2. Now, there's still this little plus sign right here, so don't lose the plus sign. So now between the 3Q and the 6, 3 and 6 can both be divided by 3. Oh, there's a Q here and no letter there, so there's nothing else I can pull. So 3Q divided by 3 is just Q. 6 divided by 3 is 2. Now, hopefully, you can see that this is Q plus 2 and this is Q plus 2. And that's the point, is I want my common GCF to be a polynomial that's exactly the same. And so when I do that, then the number that's out front, I'm going to pull those together. Well, first of all, I'm going to take the Q plus 2 and I'm going to pull those together as my GCF. Q plus 2, the GCF goes up front. Now these 2 that are left are going to go in a set of parentheses right behind it. And it's kind of like magic, but basically I just pulled this GCF out and what was left is in the parentheses, which is kind of what I did, you know, for each of the things as I was going along anyway. So yeah, so that's how you do it. Now, if I have this next one, I'm going to group the first 2 and group the second 2. And I'm going to pull out a GCF in each one. So between 2 and 12, they can both be divided by 2. M and M, they both have an M. K and not, so I can't pull anything else out. So in parentheses, 2MK divided by 2M is just a K. Minus 12M divided by 2M is 6. Plus 42 and 7, you can pull out a GCF of 7. And 42 divided by 7 is 6. minus 7k divided by 7 is k. Now, this is what we were talking about when I was talking about additive inverses, because you see I have k minus 6 and 6 minus k. They're the exact same numbers, but I am subtracting them in a different order. So 5 minus 2 is not the same thing as 2 minus 5. So I cannot just group them and pull them out like I did up here. But what I am going to do is I am going to change one of these and flip it around by, I'm going to pull out -1. So basically, when I pull out a -1, so this first, everything doesn't even change right now. Plus 7, and then I'm going to pull out a -1 because this is going to give me 6 divided by -1 is -6, and negative k divided by -1 is positive k. Now, -6 plus k can be flipped around to k minus 6, and 7 times -1 is going to be -7. So now they both have the same common factor, which is k minus 6. So I have k minus 6, and then in parentheses, I put what's left, 2m minus 7. And if I were to FOIL that all back out, I would end up with exactly what I started with. All right, so there we go. Now, if I have the zero product property, we're going to need to know the zero product property. Basically, it says if you have two numbers multiplied together and the answer is 0, one of the numbers has to be 0. The only way to get 0 as an answer to a multiplication problem is if you are multiplying by 0. So what does that mean? How does that help us, you know? So if I have two things multiplied together like I do here, but let's say I have this. Let's say I have y minus 3 times y plus 2. And I said, oh, well, that equals 0. So see, when I'm dealing with polynomials, this helps me because I know that either this first term has to equal 0 or the second term has to equal 0. So I'm going to pull this apart and I'm going to go y minus 3 has to equal 0, or y plus 2 has to equal 0. And when I can now solve these, and I end up with y equals 3, or subtract 2 from both sides, y equals -2. So I can solve these by setting them equal to 0, but I need them to all equal 0 to begin with, because if they equal something other than 0, then I have no idea anything about the numbers. But if they do equal 0, I know one of them has to be 0. All right, so there we go. That's what we're doing today. If you need help with this, please Zoom with me if you're online. If you're in person, I am probably going to go through a few of these with you. And just so you know, the answer to this question is, this next question is dolphin. I'll see you next time.